Welcome to the Chapter 6 Quiz Number 2 Review Answer Key Explanation on Chapter 6, Sections 4 and 5 for Algebra 1. So, first part we're looking at relates to Section 6.4, the solving and graphing absolute value equations and or inequalities. Now, the directions say solve and graph each absolute value equation / inequality. But all I'm concerned about you graphing are any of the inequalities, not the equations. So if we do have any inequalities like numbers 1 and 2 with our inequality symbols, you would want to refer to the chart in 6.4 in the notes. So that chart, also located in your book for 6.4, tells you the two different setups depending on the inequality symbol. So in number 1, we have a greater than or equal than symbol. So we are going to use these two setups. So in this case, our two different setups would be take what's inside the absolute value. 4x minus 5 is greater than or equal to 11, or our other setup would be 4x minus 5 is less than or equal to negative 11. And that's coming from these two inequalities right here. So then we need to solve both for x. So we'll add 5 to each side and then divide by 4. So on the left, adding 5, 4x is greater than or equal to 16, divide by 4, and x is greater than or equal to 4. On the right, add 5, 4x is less than or equal to negative 6, divide by 4, and x is less than or equal to a negative 3 over 2. So then when we are graphing these, both are or equal to's. So we will use filled in circles, greater than 4. So the arrow going greater than 4, less than negative 3 halves, arrow going left from a negative 3 halves. In number 2, what we want to do first is get the absolute value on its own. So we have to subtract 5 from each side to get rid of the addition of 5. So our actual absolute value inequality is x minus 4 is less than 2. So then our setup, again from the 6.4 chart, are these two right here. So we take what's inside the absolute value, x minus 4 is less than 2, or in this case actually, and x minus 4 is greater than negative 2. Solve for x on both by adding 4 to each side. So x is less than 6, and x is greater than 2. So in this case, we'd have open circles at 2 and 6. Less than 6 and greater than 2 means the line segment is connecting between the 2 and 6. Our next couple examples are absolute value equations. So in this case, what we wanted to keep in mind is, again, to get our absolute value alone first. So in number 3, we had to subtract 11 from each side. Then we have the absolute value of 3x minus 7 equals 26. That is what we will use to solve. So again, to solve these, you take what's inside the absolute value and you set it equal to the positive and the negative of whatever's on the right. So 3x minus 7 equals 26, and 3x minus 7 equals negative 26. Both of them we want to solve for x, so add 7 and divide by 3, and x would equal 11, and x would equal negative 19 over 3. And again, it's okay to leave these as a fraction. In number 4, our absolute value is already on its own. So 6x plus 3 equals 21, and 6x plus 3 equals negative 21. Solve for x, so subtract 3 from each side, then divide by 6, and x would equal 3, and x would equal negative 4. Number 5, because x, the absolute value of x minus 4 equals 0, 0 is neither positive nor negative. So in this case, we just set it equal, x minus 4 equals 0, and solve for x. So our only solution to this scenario would be x equals 4. And in number 6, we have to get the absolute value alone on the left. So we have to add 5 to each side to get rid of the minus 5 right here. So the absolute value of 4x plus 3 equals 35. So our two equations, 4x plus 3 equals 35, and 4x plus 3 equals a negative 35. Solve both for x, so subtract 3 and divide by 4. So x equals 8, and x equals a negative 38 over 4. Now, section 6.5, graphing linear inequalities in two variables. So the first two problems here, checking if an ordered pair is an answer. Remember, ordered pairs always go x then y. So we have to replace x and y in the inequality and solve. So replacing x and y, we get 3 times 4 plus 2 times 3 is less than or equal to 4. So is 12 plus 6 less than or equal to 4? 18 is not less than or equal to 4. So no, that would not be a solution. For number 2, x is a negative 1, y is a negative 5. So 5 times a negative 1 minus 3 times a negative 5 is greater than 4. So we have a negative 5, and then a negative 3 times a negative 5 is a positive 15. So negative 5 plus 15 is greater than 4. Is 10 greater than 4? Yes. So that ordered pair is a solution. And our last 4 examples dealing with graphing our inequalities. So in this case, if x is related just to a value, we'll always have a vertical line. And we know in this case it'll be solid because it is or equal to. So right away I know I have a solid line, and it's going to be a vertical line at negative 3 because x and the negative 3. So first thing I did, draw my vertical line at negative 3. Then we want to check point 0, 0. So I'm going to replace x with 0. 0 greater than or equal to negative 3 is true. So 0, 0 is a solution. So we would shade to the side that includes 0, 0. For number 2, y is less than 4. It's going to be a dashed line because it's just less than. And it would be a horizontal line at 4. Then check point 0, 0. So replace y with 0. Is 0 less than 4? Yes, it is. So we would shade to the side of 0, 0. In 3 and 4, remember, we want to think about y equals mx plus b. So for number 3, it's already in that format. So we know our slope is 3/4, which m is 3/4. And our y-intercept, being b, is a negative 2. So to graph this, we would start at our y-intercept at negative 2, put a point at negative 2, and our slope of 3/4. So from that point, we would go up 1, 2, 3, right 1, 2, 3, 4, and there's our next point. Then we would draw our dashed line, because it's just greater than, and we need to check point 0, 0. So we'll replace x and y with zeros. 0 is greater than 3/4 times 0 minus 2. So is 0 greater than negative 2? Yes, it is. So we would shade on the side toward 0, 0. And in number 4, we have a greater than or equal to scenario. So I know right away it's a solid line. But I need to rearrange to solve for y to get it into y equals mx plus b. So in that case, right away, I would subtract 4x from each side, and I get 2y is greater than or equal to a negative 4x plus 6. Then we need to get y alone, so we would divide everything by 2. So y is greater than or equal to a negative 2x plus 3. Our slope is always attached to x, so our slope is a negative 2. Our y-intercept is always the plus or minus, so our y-intercept is a positive 3. So in this case, we're going to start at over 0 up 3, so right here, and then follow our slope down 2, right 1, negative 2 over 1. Could do it again, down 2, right 1, and then draw our line through our points, and again, solid line. And then we need to check point 0, 0. So we're going to take 0, 0, plug it in for x and y in the original. 4 times 0 plus 2 times 0 is 0 plus 0 greater than 6. No, it is not. So 0, 0 is not a solution. So we would shade to the side opposite 0, 0.